Okay, so we've got this one, this expression here. We need to put it into partial fractions. Colleagues, first thing that we need to do is we need to determine whether it's a proper or improper fraction. So just by looking at colleagues, is this an improper fraction or is it proper or improper? Mm-hmm. It's an improper fraction, yes. Why? Can anybody tell me why it's an improper fraction? Okay, let's expand the denominator so that we see why it's an improper fraction. When we expand the denominator, let's multiply x plus 1 times x plus 1. What do we get? Let's multiply. Thank you. X squared plus, yes. So have you seen? The power of the denominator is equal to the power of the numerator. So that's why it's an improper fraction. Okay. Yes. Any questions before now so since it's an improper fraction, we have to do polynomial division. So any questions before we do the polynomial division? Mm-hmm. Mm-hmm. It's an improper fraction. Mhm. The powers are equal, or if the power for the numerator is greater than the power for the denominator. Those two conditions, then you know you're dealing with an improper fraction. So have you seen how I've wrote here the dividend x squared plus 0x plus 0. Always we have to maintain order. So, colleagues, let's divide. What are we dividing? What are we dividing? Yes. This x squared divided by this x squared. So x squared divided by x squared So we put 1. So after dividing, we multiply. 1 times x squared, 1x squared. 1 times 2x, 2x. 1 times 1, that is 1. Okay, remember the process: divide, multiply, subtract. So now we subtract. X squared minus x squared, 0x squared. So it goes 0 minus 2x, 0x minus 2x, you get negative 2x. 0 minus 1, get negative 1. What do we do next, colleagues? Should we continue the division or should we stop it? Yes. Why are we stopping it? Okay, the divisor's power is greater than this power, this 2x to the power. Yes, the reminder's power, basic. The divisor's power is greater than the reminder's power. Okay, so you end here. Okay, this is your remainder, negative 2x minus 1. So always write the remainder over the original denominator. Okay. So here, again, as I said, here we still have to break down this fraction here. Okay, we have to break it down. So we isolate it here. Important point. Whenever you've got repeated linear factors, meaning have you seen here we've got an x plus 1 and an x plus 1. Have you noticed how I've wrote the denominator for b? I haven't just written it as x plus 1, but I've also added a squared. So whenever you have repeated linear factors, just remember when you're listing down the simpler fractions, the second fraction is going to have the power 2. If we had a third x plus 1 here, it would have been written like this: c over x plus 1 cubed. If we had a third x plus 1 here in our denominator. Okay, colleagues, when you have a repeated linear factor, meaning you have like here an x plus 1 and an x plus 1, your second simple fraction, you have to put it to the power 2. If there will be a third one, you put it to the power 3, and so on and so forth. Are we okay with that, colleagues? Mhm. It's implying that you've got two factors that are the same. Mhm. If we had three factors that are the same, you would put to the power 3. So please remember that. If you have repeated linear factors are these ones, the x plus 1, x minus 3, x plus 2, x plus whatever. If they are the same, if you've got two of them, as you have seen here, we've put b over x squared, x plus 1 squared. Okay. If there were three of them, you'd add now a c plus x plus over x plus 1 cubed. If there were four of them, you add now a d plus over x plus 1 to the power 4. So please remember that point. In the previous example, we didn't have repeated linear factors like this one here. So we have to find the value of A and we have to find the value of B. Basically, we have to get rid of our denominators. Okay, so what you do to the left hand side, do it to the right hand side. So I'm going to multiply both sides by x plus 1 multiplied by x plus 1, which is the same as x plus 1 squared. Okay, x plus 1 times x plus 1 same as x plus 1 squared. So here on the left hand side, the denominator gets crossed out. On the right hand side, I'm going to multiply it with both fractions. So a over x plus 1 multiplied by x plus 1 times x plus 1, they cancel each other out. You remain with a open brackets x plus 1. B, this side, also we're going to multiply it by x plus 1 times x plus 1. So they all cancel each other out here. Okay. So you just remain with the B by itself like this. Yes. Before we move further, any questions? Are we okay with how the ax plus 1 has come about and the b? We multiplied each fraction by x plus 1 times x plus 1. Basically, x plus 1 squared. Okay, so here we can start by getting the value of b by getting rid of a. Okay, because it will be kind of hard to get the value of a. It will be, you won't be able to get rid of b in this case. Okay, in the previous example, as you saw here, you could get rid of each in any order, but in this case here, you can't get rid of b. Okay, you can only get rid of a so that you get the value of b. And once you have the value of b, you have to now solve manually. Okay, so first thing first, let's get the value of b because we can get rid of a easily. Okay, how we get rid of a? We just need to make what's in these brackets 0. Once we make that 0, we've got rid of a. So we're going to say let x equals -1. When we equate x to -1, here in this bracket we'll have a 0 and we get rid of a. So we have 2. So where there's an everywhere you see an x, substitute with a -1. So 2 times -1 minus 1 equals a, open brackets, -1 -2 times -1, that is 2. 2, we have 2 minus 1 here. -1 plus 1, that is 0. 0 times a, the a disappears. All right. So 2 minus 1, that is 1. So value of b equals 1. Excuse me. Any questions? Okay. So when we go back to our original expression, as I said, there is no way of getting rid of b so that you remain with an a. So here in this case, you substitute b equals 1 back to this original expression, okay, so that we can get the value of a. So it's going to be here, we're going to say -2x minus 1 equals a ax plus 1 plus b. Okay, so we already have our value, b equals 1. And so here we need to expand our expression here. A times x, ax. A times 1, that gives us a. B, what's the value of b? Actually, let's not even expand this because we'll do it like this. So we keep this like this. A x plus 1. Because if we expand it, we'll have to factorize it back again. So let's just keep it like this first. B equals to 1. So what we can do, because we want to isolate A by itself. So this positive 1 here, take it over the equal sign here. So that you have negative 2 x minus 1. Then this positive 1 comes here, it becomes negative 1. Then you have an A x plus 1 here. So negative 2 x minus, so this negative 1 minus negative 1, that gives us negative 2. Mm-hmm. Which one? Which one? Oh, this one here. Okay, minus 1. On our left hand side, we can factorize this here. Okay, we can factorize this. Our common factor is negative 2. Negative 2x divided by 2, you get x. Negative 2 divided by negative 2, that's you get positive 1. Now remember, we still want to find, we're trying to find the value of a. So divide both sides by x plus 1. A equals negative 2. Any questions? Mm-hmm. Mm-hmm. Okay. The purpose of making x negative 1 was to get rid of a, so that we just remain with b, so that we get the value of b. That's why we did that. Was it, so that it becomes 0. Okay, madam? So that it becomes 0. The purpose is to make it 0. Yes, once you made it 0, then Uh, you've got rid of the other variable. Now remember, with these questions, this is just one way of solving it. There are many ways of solving it. Okay, many ways of solving these things. Okay, but once you reach a stage like this, and you've got two variables, okay, just look how can I get rid of one. Once you get rid of the other one, you get the value. Okay, so our with Mhm. Mhm. Yeah. You're talking about this part here. Okay. Let me just get the other questions so that I'll answer all of them in order. Yes. What was the other question? Okay. I had the raise hand notification, so I thought there was another question. Okay. Let me answer your question. So, madam, I said each fraction you're multiplying it with x plus one times x plus one. So for a over x plus one multiplied by x plus one times x plus one. Okay. This x plus 1, it cancels one of these. So you remain with a times x plus 1. Then for b, remember the x plus 1 squared is the same as also x plus 1 times x plus 1, right? So these will cancel each other. That's how b remained by itself. Is that okay, madam? That's yes, that's how we got that. Okay. So A is negative what? A is let's see, it was negative 2. plus b is 1. So this positive and negative make negative, so it's 1 minus 2 over x plus 1 plus 1 over x plus 1 squared here. This one has to be squared. That is the answer.